Hey there, welcome to Integrals Made Easy. If you've ever wondered what exactly is an integral and why does every science and engineering student seem terrified of it, don't worry, you're about to find out, and it's not as scary as it sounds. Here's the thing, integrals are everywhere. They're used to calculate the distance your car traveled when your speed keeps changing, they're used in economics to measure total profit over time, and in medicine to analyze blood flow or drug concentration. Think of an integral as a superpowered calculator that can add up an infinity number of tiny things, like slices of area or pieces of change, to give you a total. Cool, right? Let's get to the heart of it. At its core, an integral is a way to add up infinitely many little things. Imagine you want to find the area under a curve, like this one here. This is the function f of x equals x squared. It's not a simple rectangle or triangle, so you can't use basic geometry formulas, but we can estimate the area by slicing it into lots of narrow rectangles, like this. Each rectangle gives a little piece of the area, and as we add more and more of them, our estimate gets closer to the actual area. Now imagine making the width of those rectangles super small, infinitely small. That's what an integral does. It takes the limit of all of those rectangles and gives us the exact area under the curve. There are two main types of integrals you'll encounter. First, the definite integral, which looks like this one here. So you start at a point A and you end at a point B. So you're trying to find the area under a curve from a point A to a point B. And that'll give you an exact value under that curve. So, and if you were trying to find the area under a curve of an indefinite integral, it'll give you an antiderivative, not an exact value like the definite integral would. So when you integrate a function, you're answering what function has this as its derivative. And don't forget to add plus c, the constant of integration, because any constant disappears when you take a derivative. Now let's walk through a visual example. So we're going to do an indefinite integral of the integral of x squared d of x. So we're going to use the reverse power rule. And to solve this, we're going to add 1 to the exponent and divide by the new exponent. So it'll become x cubed over 3 plus c. And that's our answer to this integral. Now we're going to do a second problem. And this one is going to be a definite integral. So it's going to be the integral of x d of x from 1 to 3. And to solve this, we're going to do the same thing, reverse power rule, and find the antiderivative. And we're going to do add 1 to the exponent, so x squared, and then divide by the new exponent, x squared over 2. But now we have boundaries, so we have to evaluate that to get our value. So when you plug in 3, you always do b minus a, so you're going to plug in 3 for x minus the a value as x. And then this will give you a value of 4. So that means that the area under the curve f of x equals x from 1 to 3 is exactly 4. Now let's do a quick recap of everything that we've learned in this video. So we learned that an integral is a way to add up infinitely small pieces like area under a curve. There are definite integrals which give a number and indefinite integrals which give a function. Integrals are the reverse of derivatives. They help us move from rate of change back to total amount. And they're not just theory. They show up in physics, economics, biology, and more. So that's the end of today's episode. In the next episode, we're going hands-on. I'll teach you the rules of integration, starting with the basic power rule, and you'll learn how to solve any beginner-level integral. Want to test your understanding right now? Download the free worksheet linked below. If you found this helpful, make sure to hit that like button, subscribe, and turn on the bell so you don't miss what's next. Have a great day.